This podcast is brought to you by the Albany Public Library main branch and the generosity of listeners like you. What is a podcast? God, Daddy, these people talk as much as you do. Razib Khan's Unsupervised Learning.
Thanks for listening to the ungated version of the Unsupervised Learning podcast. If you want to read some essays on some of these topics, please check out razib.substack.com. Again, that's razib.substack.com. Thank you.
You know that genetics plays a huge role in our health, and more people are using genetic testing to determine risk for diseases like cancer for themselves and their kids than ever before. So I want to tell you about Orchid. It's the only company that does whole genome testing for embryos, testing before your child is born. If you're doing IVF, this is a clear choice now because now you can reduce risk for thousands of single gene disorders, including heritable forms of autism, pediatric cancers, and birth defects. Check them out at orchidhealth.com.
Hey everybody, this is Razib with the Unsupervised Learning Podcast. Today, I am with my friend Nicholas Cassimatis, actually Dr. Nicholas Cassimatis. But before we start, I do want to say one thing. I say this every now and then, but not that often. Can you please rate my show on Spotify and Apple if you're listening to it on those platforms? I don't know what else is out there. I used to use Stitcher, but they shut Stitcher down. But basically, if you rate it positively, it's good. If you review it, it's even better. And the reason is, more distribution and people can listen to, great podcasts with individuals like Dr. Cassimatis here. And so I just want to say that. I don't say that often. I know it takes like a couple of minutes out of your day. Please do it. I don't have an ambition of getting up there with thousands of reviews, but I'm in the mid 150s, I think, right now. So on Apple and 144 on Spotify. I'd like to get a little higher. I know that there's thousands and thousands of people that listen to this. So if just, every other person could write a review or review this, that would be great. Okay, that's boring. I want to talk about interesting things. We are going to be talking about artificial intelligence today with someone who is steeped in the field. Introduce Nick as Dr. Cassimatis, and I know Nick here in Austin in the tech scene a bit. So just so if I seem a little bit fresh with him, I'm not being inappropriate. He's just a friend of mine. But he is also a doctor who has a Ph.D. from Massachusetts Institute of Technology, MIT, under Marvin Minsky, who, those of you who know something about popular science and artificial intelligence, that name will ring a bell. We can talk about this, but my impression is he's probably the most prominent artificial intelligence researcher in the second half of the 20th century. But Nick knows, he probably has his own biased opinions about that. He was a postdoc, Naval Research Lab. He was a professor. He was an academic at RPI in cognitive science and computer science. And then he, went into industry, worked at Yahoo on deep natural language, and then Samsung. He was the head of AI research. And now he is the founder of a startup called Dry.ai, which I do use in various capacities, and we will talk about that later. You have probably seen Dry links here and there on the on the newsletter. Basically, I wanted to talk to Nick today because there's a whole aspect of him that is not surfaced very much, I think, at least in the social context that I see him, and which is his academic aspect as a researcher, and all the stuff he did and all of his insights. And he has certain opinions and conclusions, but people like me that have opinions and conclusions about artificial intelligence, we don't really know anything, to be honest. And I'm sure he has certain opinions about genetics, but I don't really know much, So I'm trying to give the analogy here of why it's important to listen to the area experts, even though we should be also careful appeals to authority. But Nick knows his stuff. And so I'm going to try to pour some of that knowledge out in this podcast. The first thing I do want to ask you, I have notes that I put in here about this, actually. what is artificial intelligence? How do you define it? And also, what is deep natural language? These are words that, people think they know, but, often these, straightforward words are misleading when they're taken out of colloquial context. So why don't you just start from there?
Sure, Razib. Yeah, thanks for having me, by the way. Artificial intelligence, it's a hard thing to define. To me, it just means making computers do things that we would characterize as being intelligent in people. That's simple, basically. A lot of people want to define intelligence when they start talking about AI, but really, there's no really good definition of life. It really doesn't matter what your definition of life is to study biology. I mean, most people study biology and they might have some memorized definition of what life is, but it never really affects the actual details of the science. Like whether a virus is a living thing or not really doesn't really matter for any actual scientific inquiry into like how viruses work, how they spread, et cetera, et cetera. So I don't worry too much about what AI means, but yeah, that's basically, I think, how I characterize AI is get computers to do things we call intelligent.
Yeah, so I think this semantic issue is more for people on the outside because in many cases, like you said, I mean, this is, I don't want to sound like a hater, but I will sound like a hater. Philosophy of biology, or philosophy of science in general, philosophy of physics, whatever, no one's really pays attention to it when you're doing the science because you're a practitioner and you're doing it. So this is like, Supreme Court saying that they know when something's obscene, they know porn when they see it, So obviously, like nobody on a porn set is, what is pornography? It's just like everyone knows what's going on here. So with artificial intelligence, we could talk about the Turing test and all these other things, but the reality is, I'm assuming when you're in the lab or when you're working on the computer and whatnot, it's just like you're not like having deep philosophical. I mean, you're not. I mean, just most people don't have deep philosophical reflections, but researchers are trying to get publications out there. They're trying to solve hard problems, and so they're probably not going to. Actually, I know they aren't gonna, mull over insoluble problems, which is what a lot of philosophy is, to be candid. But so, what is deep natural language, though? Again, deep, natural, and language. All these terms are straightforward, but together, what do they mean?
Right. I think when people first started using that term about 20 years ago, probably, I would say, when I really started using it myself in my own research about 10, 15 years ago. And at the time, most computers that understood natural language understood it at a very shallow level. So the field of natural language processing was very good at determining whether classifying the part of speech of a word, or it was very good at classifying what the topic of a document was. Was it about finance? Was it about sports? Was it about weather? And so our goal at the time in my own research and my lab's research was to figure out how to have much deeper understanding of what is being said, what people are talking about, so that you could do a much better job of, conversing with them, solving problems, and being useful. So that's really what deep natural language means. It has actually nothing to do in that context with deep learning.
I see. Yeah. There's only a finite number of words out there, and so things start overlapping and people get confused. So I just want to clarify that. I know, so you worked under Marvin Minsky. I mean, he's a famous dude. He was one of the type of people, I mean, I think literally he was on the edge.org website, part of Brockman's, intellectual scientific salon. So you got your PhD, you have, as they say, good pedigree. So you are a doctorate under a scientific celebrity, but also someone who made a lot of original contributions, kind of pioneered modern artificial intelligence from what I remember reading after World War II. Obviously, there's other people out there, but Minsky looms large. I know that there are arguments and theories about the different types of artificial intelligence and philosophy, and I vaguely remember reading stuff about top down and bottom up and all these things. Can you just give us a general sense of, I don't know, let's say paleo AI, like AI in the 60s, 70s, 80s, before you came onto the scene, before, all of the things like neural networks and everything like that were in vogue?
Sure, yeah. And Marvin Minsky was involved in a lot of it and was actually on a lot of sides of it actually quite controversial about it. So there was a boom in neural nets actually. I would say early 60s. I don't know the exact dates, but that gives you a time frame. And Marvin Minsky wrote a book called Perceptrons, where he and Seymour Papert proved certain limitations of neural networks, and that caused the field to abandon neural networks for a while. And what you see now, what you saw after that was this, what's generally called symbolic AI. And that means several things. So, for example, one way of characterizing it, so I'll just give you some broad examples of how people characterize that. So, one of the earliest approaches was based on search. And so the sort of idea there is if you're playing a game of chess, for example, and you want to find the best move, what you do is you think, okay, if what are my possible moves? Let me imagine I do each of those moves. And then let me imagine the moves my opponent can make. And let me do that, for 10 steps forward. And let me therefore search through the sequence of possible moves I can make, my opponent can make, and find the most optimal move. Another example of search would be if you're trying to plan a path from, like your GPS does, to plan a path from Boston, say, to New York, when you're driving. What you would do is you'd start by you'd search all the possible routes. You go, okay, I'm on a certain street right now. I can take 3 streets from here, and imagine what would happen if I take each one. And again, you search through the possibility of doing all those possibilities. So that approach to natural language, to AI was based on search. It was quite powerful, and that is what a lot of people identified AI as being search algorithms, where you're just searching through spaces. And so right now, for example, when you use your phone or your car to navigate to somewhere, you are using what was once considered an AI algorithm. And so that's one approach to AI. Another approach to AI was based on theorem proving. And so the idea of theorem proving is in AI is this. Let's say, for example, you want to solve a problem. And so what you could characterize it as a theorem proving problem. So basically the actions you can take are your axioms, and the current state of the world are the facts that you take to be true, and the desired state of the world would be the theorem you're trying to prove. And then so you feed that to a computer that can prove theorems, and the proof it generates turns out to be a sequence of actions that will help you achieve your goal. It's kind of abstract, but it turns out that you can characterize a lot of problems as theorem proving problems, and that has a lot of great benefits. Once you characterize things in terms of theorem proving, you can make all kinds of proofs about what a system does, what it can be guaranteed to do, whether it's going to be guaranteed to correct or not being guaranteed to correct. And so that's the opposite of neural nets today, right? Where basically the problem we have with LLMs and ChatGPT and so forth is that they make stuff up, and we really have no way of knowing why they're making stuff up. Whereas these other approaches to AI that were prior to that actually were very explicit about the actual knowledge they had encoded into the system. So there were there's several other kinds of symbolic AI, but I think that gives you a flavor of what AI was once compared to what it is now. And there's some trade-offs, but I hope that answers your question.
Yeah. It's interesting. I know about the whole search stuff. I think anyone who's on the edge of tech knows the importance of search and search algorithms in modern technology. It's interesting you point out the theorem, solving. Theorems are a big deal, obviously. The origin of real modern mathematics, and they go back to the Greeks. But for various reasons, the American academia or educational establishment, we have de-emphasized theorems. So, for example, inductive learning in math as opposed to deductive. So when you're saying a theorem, I think a lot of people kind of know what you're talking about, but they haven't done very many theorems. I haven't done very many. I've taken applied math, but they just kind of stopped emphasizing proofs. over the past generation or so. In contrast with search, I think a lot of people are just imagining what's going on. They feel like they have an intuition, and sorting algorithms and all these other things are a big deal in computer science. And so if you have friends that are in tech, that are devs, you've heard about that. So it's interesting how, these two things have different saliences, I think, to us in 2024. And that's just because of the practical application. I want to go back. Can you tell the audience what a neural network is? Because again, neural, that sounds like biology, but obviously it's not biology.
Sure. Neural networks are at best a crude approximation of how neurons actually work. I mean, at the very best. But neural network, trying to think of the easiest, simplest way to characterize this, would be this. So let's say take the simplest example of a neural network. Let's say we're trying we're looking at sort of pieces of fruit, and we're trying to decide whether they are raspberries or whether they're oranges, say, right? Let's make that bananas or oranges. And so let's say there's two features that matter to sort of help you decide that. One would be the color of the object, and the other one would be its shape. And so you can imagine basically having a graph, if that means anything to people. So basically you have, let's say you have a neuron, and a neuron encodes the color, and the other neuron encodes the shape. And then you feed that into another neuron, which encodes the category of the object. And so basically, and so let's say you're trying to decide whether it's a strawberry or not. When you have the color red feeding into the strawberry neuron, so when the color of red neuron when the color neuron feeds into when the red neuron feeds into the category neuron, you want a high activation of the category neuron so it says strawberry. When the sort of yellow neuron feeds into the strawberry neuron, you want a low activation because you don't want yellow to make you think of strawberry. So the idea is you can think of all these neurons that encode either concepts, or they encode things that you see in your environment, or pixels, for example, in your retina. And they're all connected to each other this way, and they're sort of charging each other up. And the degree to which they charge each other up decides what kind of inferences you make about what's happening. And the challenge of training a neural network is to sort of decide how much one neuron will charge another neuron in such a way that it makes the correct predictions.
Yeah, I mean, what is this? Could you say that you're training the neurons, or is that not the right word?
People say you're training the network, and the way you train the network is deciding how much one neuron will activate another.
Yeah, and I want to go back to neural networks because I feel like, they burst onto the scene, then they kind of, disappeared a bit, and now they're back, and I want to talk a little bit about that. But first, we got you sent me some notes, and there's various things that I want to touch on. So what was Eliza? I think I've read about Eliza, but I forgot about Eliza. Like, it seems very familiar.
Yeah, it's good that you mentioned that. I think it was in the 60s, might have been early 70s, but thereabouts. Someone created a computer that, a computer program, and you'd go there and you'd talk to it, and it acted as a therapist. And you would say something like, I just had an argument with my husband. He was complaining about XYZ, and it would say, oh, tell me more about that. And it would have these simple little rules that would say things, like, tell me more about that. Or it would say things like, oh, what does that make you think of? So basically it was basically something that had a few canned responses to what you would say, but it was intoxicating to people. People would sit there and have conversations, become emotionally involved with the program. So it was really probably the first chatbot ever, certainly the first one that anybody ever noticed. And it was quite it caused a lot of hype in AI at the time. And something that, taking a quick step back, people don't realize AI has been through several hype stages. We've had, you might remember the Watson hype stage. And then when in the 90s, when AI would beat humans at chess, there was that phase. There's lots of phases of hype. This is the biggest one we have right now. But there was an early one caused in part by Eliza. And so I think the lesson a lot of people drew from it at the time, well, the immediate lesson was, oh my God, computers are really smart. They understand us. They're very emotional. They're going to take over the world. But pretty quickly, people saw the limitations of that. And so then the lesson was, the lesson people should have learned from that was people are pretty shallow, actually. They will attribute humanity and they will anthropomorphize things that really don't deserve it. I think that's part of the appeal of pets, frankly. And so basically, I think, in some way, ChatGPT, although it's a million times more impressive than Eliza and extremely useful in a lot of ways, still, people's first encounter of it makes them think that it's as intelligent as a person, but when you actually try to get it to do a lot of normal things people can do, it can't do them. So there's just this lesson that there's a difference between sounding smart and being smart. And I think Eliza was really the first thing that sort of exploited the fact that people sometimes infer things that sound smart are smart.
You're alluding here, I think, to the Turing test in a way, right?
Yeah, it's a similar point. It is a similar point where basically, if the Turing test, I think Turing's different. I really haven't read the actual original Turing text, so I don't want to misattribute it to him. But what people tend to think of the Turing test is that if I give you a computer and you interact with it and you think it's human, then that means it's intelligent. And I think that's wrong in two ways. One is you can be intelligent without being human-like, and two, you can sound human and actually not be that intelligent. And you can even sound intelligent not being that intelligent. I mean, in our normal
Many
lives,
such cases.
Yeah, exactly. I mean, everybody knows someone who really isn't very smart, but they're really good at regurgitating smart things other people have said. In fact, that's what most people in engineering think about people not in engineering, in the humanities, right? And so basically, people, like when they're judging people, are able to sort of separate sort of actual intelligence with maybe sort of regurgitated intelligence. But they need to get better at that with computers as well.
Yeah, so we've been at this since, so I looked it up. Eliza was 64 to 67. And, I remember these sorts of chatbots even when I was a kid in the 90s. And they were really cool at first because it was like, is this a computer? Is this a human? What's going on here? But it's more about us. These chatbots are telling us it's more about evolutionary psychology, human psychology in a way, because Eliza was, the source code, they just recently rediscovered it. They used to not publish code back then, but, they had to use abstraction and other things and, all of the basic stuff that you see. But it's programming language. It's a programming language that's just like taking inputs and outputs. And people think it's human, or the people think it's intelligent. Like, what? This is crazy. But what is intelligence? What is? These things are. It's kind of like it when you see it, but then people see intelligence in computers, and the pundit Matt Iglesias likes to say all of these criticisms of why GPT is not. A lot of the criticism of why GPT is clearly not intelligent apply to a lot of humans. So it's like people are too stupid to realize, well, how do I know that you're intelligent or conscious? So it's like the whole thing is just kind of like, I want to use a swear, it's kind of like a mind fuck, It's like, okay, wait, what's going on here? And so I think artificial intelligence is fascinating because, obviously we care about it, we care about automation, but also it comes back to us and it's like, wait, what's going on with us? Like, how would it's a science fiction story. This is a science fiction story where artificial general intelligence emerges and it concludes humans are not intelligent life, But it's like, it's not implausible, right? And I do feel sorry, by the way, that we are not a YouTube show because as you were talking about neural networks, I was imagining some schematics that I've seen before. And you were kind of like moving your head. I mean, I think you were imagining the same thing in your head. So neural networks are usually illustrated with certain schematics, and it's like much easier.
That's right.
A picture in that case is worth 1,000 a year your words. And so I apologize for that. Anyone who's interested, just Google neural networks or go to Wikipedia. You'll see it, and the image makes it really clear. But I wanted to bring up neural networks because, I read stuff in the 90s, I think, 2000s, by now Gary Marcus, who was a big AI skeptic. Now he's a cognitive scientist, psychologist, although he left academia a while ago. In any case, one of his books about cognitive science psychology that I read actually was really, really skeptical of neural networks. I think it was written in the late 90s or early 2000s. But the point is, the hype cycles have come and gone, come and gone, come and gone. And I'm of an age where robots and artificial general intelligence, was supposed to show up at any moment. And so, you start to get cynical. But there was Deep Blue, Watson. I remember actually the Watson hype cycle. That was I was an adult then. It was very clear. The Singularity Institute sponsored a kind of a viewing of the Jeopardy episode. So for context for people, Watson won at Jeopardy, right?
That's right.
Yeah, so that was a big deal. But obviously, Watson's nothing like GPT. Didn't use the same technologies or the same underlying, LLMs and transformers. All those things weren't around then. So it was a totally different thing. What I remember, I think Watson or Deep Blue, which I think also is IBM. I think they were supposedly going to do protein folding and unfolding. Like that was what they were ultimately their horse. And just so the listeners out there understand. Protein folding and unfolding is super important because DNA turns into RNA, which turns into proteins. And proteins are, you can create, pharmaceuticals out of this. But a lot of pharmaceutical drug development is basically iterative. It's trial and error. That takes a lot of time. So if you can figure out how the DNA maps onto a protein product, that will shorten a lot of the trial and error. And that's why computation has become more and more important. And I believe DeepMind, the more recent iteration from Google, has, gotten at this somewhat. So there are some real practical applications out there that AI is important. Going back to Minsky, I want to ask you, what years did you get your PhD? Like, where were you when you were working under him?
Roughly 97 to 2002.
So how did he feel about the field then? Like, what was your sense?
Yeah, no, I mean, he spent almost all of his time talking about how he felt about the field. So at the time, we think of machine learning as being this sort of, at least some people do, of this sort of more modern thing. But at the time, that's when neural networks, so I would say the 90s were basically where neural networks were really not neural networks, machine learning was starting to become the dominant part of AI. And what that really meant at the time was rather than doing these kind of reasoning or search-based things based on knowledge that I was talking about earlier, they would not bother trying to give knowledge to the computer, but instead they would give it a ton of training data and hope it would sort of infer knowledge. And that was becoming dominant in the field. And Marvin Minsky hated that. That was one of his main themes was, pushing for reasoning and knowledge, and planning. And another one of his themes was, diversity versus uniformity. And what that meant in that context was, everybody else, the general pattern is somebody invents a certain kind of algorithm or class of algorithms inside of artificial intelligence, and then they try to claim that algorithm will be able to do everything. So, right now we obviously are living in a world where a lot of people in AI are trying to push deep neural nets to be able to do everything, and that's what their belief is, and that's sort of the foundations of their, it's the premise behind a lot of their work. And his thesis was, actually what you needed to do is not have one method that could do everything, but actually find ways of creating systems that created combinations of these methods. So his famous book, The Society of Mind, meant that the mind, rather than being one specific monolithic algorithm, was instead of a collection or community of algorithms that were working together to be intelligent. So those were the two things I would say. He was sort of arguing for a kind of decentralization, and he was also arguing for a kind of, he was arguing against big data. Let's call it that.
Yeah. So I mean, yeah, big data. I mean, machine learning is like you're training these machine learning algorithms, and anyone who reads my stuff has seen plots generated with machine learning, where it's not put in, the information is not put in there a priori. So for example, okay, I want to like find population structure in this set of individuals, and you just put in some parameters in there, and then it like looks in there and creates these clusters, and it does it by maximizing the likelihood or something like that. There's a function in there that it's maximizing, but you don't know what's going to come out because it's based on what you put in.
That's right. And those machine learning algorithms are extremely useful. I'm not trying to argue that they're not useful, and neither was he. I think in the context of actually trying to make computers that are intelligent as people, which was his goal. Observe, for example, ChatGPT, super impressive, but it does take billions of words of data, training data to train it. I hundreds of billions. I don't have the exact number in my head, but humans learn language with 100,000 or a million words in their training data. So it's several orders of magnitude. It's almost like it's several orders of magnitude more data than people have. And so how is that? So there must be something else going on besides what deep neural nets are doing and how people are learning. And also the other thing to realize is this gets back to what you were saying earlier about the Turing test. The way when deep neural nets, when LLMs and things like ChatGPT start to sort of show their limitations when you try to have them reason or plan or actually solve problems. I mean, if you actually are trying to plan a specific trip with a neural net, with a ChatGPT, for example, it's not that great actually at keeping track of where you're going and when, and your connections and this or that, and a lot of your preferences and all that. Whereas, and so in contexts like that, you have these other algorithms that are more useful at that kind of thing. And I think what Marvin was trying to sort of encourage people was to get better using those kinds of algorithms, and people are very good at those kinds of algorithms. So you will get kids who are 5 or 10 years old who can out-reason ChatGPT in a lot of context. And so that's anyway. So that's I forget how we got onto that, but that is
no. Talking about machine learning, I want to say this is a very fascinating point. And I think what it reminds me of, I use an analogy. Fermat's last theorem, obviously, part of it was lost, and so they couldn't figure it out. It was short. We knew that it was short. So when it was solved by Andrew Wiles, it was very long. So Andrew Wiles got to the same endpoint in an incredibly tortuous manner, using extremely complicated mathematical fields that were developed within the last couple of decades. While Fermat got to a quick. Now it could be Fermat was just wrong. That's one hypothesis. I think I'm not gonna lie. I actually wonder if that's the case, but it could be that he was right and he got to it in like very few steps somehow. Okay. And so to me, that illustrates, you can get to the same endpoint. So what LLMs, that large language models, and I've done multiple podcasts on this. I don't want to belabel what an LLM is. But basically, LLMs, like they've brute forced their way into seeming human, into seeming clever.
Right.
We are not brute force. I mean, like our brains are light. They're packed well. They're sloppy in some ways, but they're incredible in other ways. And so, we achieve a state of seeming human very efficiently. I know that we got some electricity going through our system. We got to eat, but we use a lot less energy than these big dumb pieces of metal. I'm still going to say they're dumb because they're not controlling the world yet, and I hope they're not like offended. But in any case, machine learning. So I have a friend who works in agricultural genetics, and she's always saying like, it's like a buzzword. Like regression is machine learning. How would you define machine learning? I mean, you kind of went around the edge, but let's drill down.
Well, there's the more literal definition. The most literal definition is basically that computers, by interacting with the world, develop a capability they didn't have before they started interacting with the world. So they started out not being able to do something, not knowing something, and then they observe, they act, they plan, and then basically after a while they can do it. That's the most general. And there's lots of ways to learn. You can learn with lots of big data. You can learn by just speculating in your head and trying to prove theorems what they're going to do.
Or simulations,
Or simulations. Yeah, no, exactly. Simulation is a great way of learning. But I think colloquially, today, what machine learning means, and definitely in the field, what it means using huge amounts of data to train computers to be smart. So that's what machine learning is.
So we didn't have the theory. So I like to example I like to use is a lot of phylogenetic programs today. They use MCMCs, and the MCMC like algorithm, the Markov chain Monte Carlo. I like to say, and people have heard me. I mean, you could have done this in ancient Egypt if the pharaoh was like, you guys are all going to compute. Right. MCMCs right now. Right. You could have done it. You could have brute forced it. But the reality is, you need a computer to do it efficiently in a realistic time scale. And some of these things you're talking about, like search and stuff like that, people who have worked in the field or adjacent to it, they know that you can't do it exhaustively. You're going to run out of like all the time in the universe. So a lot of these methods are based on how to do shortcuts and sampling the space in a way that will make it tractable. Well, okay, so MCMCs, you could do it. The theory was the theory was there a long time ago, but implementing it is a thing of the last couple of decades. Is machine learning like that, where the theory was always there, but we didn't have the computers?
It is actually, yeah. I mean, there was a thesis. So backpropagation is the underlying algorithm behind a lot of deep learning today. I won't explain what it is, but it just is what the algorithm is. It is the core algorithm. And somebody found a thesis, I think, from someone, Applied Statistics guy at Harvard, roughly 1970, that actually had backpropagation in it. He didn't call it that. He didn't have the neural net metaphor, but it was basically backpropagation. And then roughly in the 80s, David Rumelhart rediscovered backpropagation in neural networks, and there was a big boom of neural networks starting, I don't know, roughly in the mid 80s, and then that sort of, there were some nice advances there, but then that sort of, reached an asymptote. There stopped being advances. And then we rediscovered neural networks again, 10, 15 years ago in some popular way. And there was more advances. And at the beginning of that first wave of advances, say 10, 15 years ago, a lot of the advances really came from just having more computational power. I mean, there were small refinements, but it was mostly computational power. Since then, there have been additional advances, all of this is very vexing to sort of somebody who's been in the field. So I'm embarrassed to tell people I do AI because it makes you, it makes you look like a follower or a trend. You're trying to person. I was doing it when there was an AI.
You actually are not a tool.
Exactly. Well, literally, when I started working on AI, there was a big hype cycle and investment cycle with VCs in the 80s and 90s, mostly, in the 80s, mostly in artificial intelligence, and then it collapsed. There was a bust, an AI bust, and they called it the AI winter. So literally, when I first started doing AI, everybody told me not to do it. It was career suicide, and it was quite a challenge, actually, in a lot of ways, to just get a job doing AI. So I've seen basically over the years, but also have read before my time and observed it since after my time, that basically, some Marvel will come out. It was Eliza once. It was Watson some other point. It was the deep mind, the chess playing Deep Blue, I think it was called. And everybody gets really excited and hyped about it. And there's a big sequence of advances, and then there's sort of a hangover. And we rediscover the same things over and over again. Like literally, people. And another interesting thing is Jeff Hinton it was his lab that a lot of the most recent sort of the deep mind stuff started in 15 years ago. But back in the 80s, Hinton was actually against backpropagation. because he was for unsupervised learning versus supervised learning. I could explain what that means, but basically it was unsupervised learning, as you might know, Razib, means when you learn without training data, and supervised learning means when the computer makes an inference and you say whether it was right or wrong, and you're constantly giving it that feedback. And so deep neural networks are very much about supervised learning, and Jeff Hinton was about unsupervised learning. So just lots of ironies in the field. Lots of people who think he invented AI, even though he's one of the best people in the field. AI was invented long before him. So somebody needs to sit down and just dissect all the sort of false conventional wisdom in AI right now, just sort of as a sort of a reality check on how good sort of actual popular science is at actually conveying stuff.
Well, I mean, so I've heard of back propagation. I've actually never looked at what it specifically was, and I just looked. So I'm going to give you the one sentence in Wikipedia with just so why you do not want to explain it. Back propagation computes the gradient in weight space of a feed-forward neural network with respect to a loss function. So I get it. And I started looking, I mean, I've done, some like linear algebra and other things like that. So matrix multiplication is not, but it looks a little gnarly. I
mean, there's a simple intuition behind it, which is that there's this thing called gradient descent, which you might have heard about you definitely have heard about in statistics, which is that, all right, I have a model and it has parameters that generate a prediction. Let me tweak those parameters. So, and I run some predictions off the model. I see which direction they fail in. So I tweak the parameters just so they move me a little bit more in the direction I want to go. So that's as gradient descent. It's like you're climbing a hill.
Hill climbing
algorithm. And so back propagation is just multi-layers of that. So rather than having so in classic regression, you have sort of your input and your output, and you're correlating those two, and you're using hill climbing to find the best sort of fit. Back propagation is several sequences of that. That's really all it is.
Yeah. So, I mean, I think this is true, but, I had a friend who was a computer scientist who was also studying genetics in the 2000s. He would always say, evolution is basically just like a hill climbing algorithm, and like, that's how we think about adaptive landscapes and maximizing like fitness functions and all these things. So, nature's one, like the basic underlying abstractions are very, very general. So before we get, into more contemporary issues, I guess, can you tell us what transformers are?
Sure. Yes. So let me find the simplest way of putting this. Transformers are, let's take the simplest example. Let's say basically you want to translate French into English. You could create a neural network whose input is French and whose output is English. And there's these middle layers that are being trained by your neural network training algorithm. And they're basically transforming French into English. And so and the beauty of that is those internal layers are finding some encoding of the meaning and the actual structure of what's being said in French that you and I don't understand, but is useful for the computer, for the neural network. So anyway, that's what transformation is at some level. And so basically you can the way sort of transformer architectures work is that they're and when you create this internal layer in a transformation, what's nice about it is that it compresses superficial features. And so, for example, if I have let's say a paragraph in French and a paragraph in English, but I can condense it into sort of, let's say 100 bits in a vector, or 100 dimensions in a vector, or I can. So if I have basically something I'm normally representing with thousands of bits of input, but I compress it down into 100 bits. That sort of compressed layer actually is what it's doing is encoding the meaning really of what was said. And so transformer networks are basically exploiting that kind of compression and encoding to generate a lot of intelligent stuff. That's the best I could do colloquially, I think, right now.
So yeah, and it's it's a relatively newer system. So I just wanted to check. Google Translate switched into transformer type operations around like 2016. I do think, like, as you were talking about this, I know that it's difficult because these are technical. I can like really concretely understand why visual spatial skills are important in math and stuff like that, because I'm imagining how we would do this on YouTube or something like that, where when you say a vector, I know what that is automatically because I have enough math, but some of the listeners probably don't know automatically what a vector is, and I'm not going to ask you to like describe a vector, whatever. If you don't know, look it up. But what I would do is like I would cut away, or I would like do like a split, and like I would show a vector as you're talking about a vector, and everything would be understandable. Anyways, neither here nor there, but
here's a more colloquial way of thinking about it, is that basically if you think about an important part of conversation is context, I think, right? So if I say, the bug is big, if I'm in a computer programming context, then the bug means a problem with my code. If I'm in sort of a biological context, it means an insect, say, of some sort. And so context matters a lot. And the problem is neural networks, when you make their inputs too large, stop working. And so therefore you can't give as context to a neural network all of human knowledge, or you can't even give as context to it really everything that was said in the past 10 to 30 minutes of a conversation, every single word. So what these transformer layers do is that they compress basically context into a small enough input that you can feed it back into the neural network as context. So the reason these neural networks are doing so well in part is because they're doing much better at context than they were doing 20 years ago. And this transformation that lets you sort of compress the context in a way that you can feed it back into the network is basically part of the secret sauce.
Okay.
Which isn't a secret anymore.
Yeah, we've been talking about a lot of technical things. By the way, there is a podcast called Unsupervised Learning that I think has more reviews than mine. My goal is ultimately to surpass that podcast, but we'll see. It's a really good name, not gonna lie. It's it's on security AI. It's got Daniel Messler. 421 episodes. Oh wait, he's got 122 ratings. I have more ratings than him now. Yeah, that's what I'm talking about. Sorry.
That's fine.
421 episodes. He must be starting to be annoyed because like it's a really good name. He got the brand, and now like I have like another podcast, and it's not as like it's more. It's a I picked the name because I was trying to describe the way I have lived my life, which is with minimal supervision, so it wasn't like the technical meaning, but whatever. I still like the name. Let's talk about, stuff that's a little bit easier to grasp for people, like what they're interested in. So, as of, I'm talking to you right now, but the other day I talked to a friend of mine who's a doomer, pretty much a doomer. I'll give you the quote. This is Jim Miller. The listeners will have already listened to that podcast when they're listening to you. So Jim Miller basically is an economist at Smith. He's been talking about like, transhumanism and all this stuff for a while, and singularity. And, he basically believes that the next like 10 to 20 years are going to be great, that AI is going to transform everything and increase productivity and all this stuff. But, he thinks that there's a 90% chance that we will be exterminated. I asked him what his P-doom was. And so he thinks everything's going to be great until we're rendered extinct, like right up until that moment. So you're smirking, and, I know you well enough to know why you're smirking, but what is your P-doom?
Right. I think it's unknown. I think there's two flaws in that argument. Having not listened to his argument, I'll guess that there's two flaws in it. One is he's assuming technology is farther along than it is, and I don't think it is. And the second flaw is he's assuming that basically, intelligence, an artificial intelligent being will spontaneously become selfish or malevolent, or ambitious or something. And so I think those are both wrong. So, I mean, it's kind of hard to sit and argue. I get given you some, vague arguments regarding how good the technology actually is. I mean, it's been 14 months now, 15 months, however long it's been since ChatGPT came out. And, you and I both have friends and have been in social settings where at the time everybody thought, it was going to put a lot of people out of business in 5 years. And I have informal bets with people about 5 years where we're going to have project managers and secretaries. And I say we will. And so I think, we need to sort of be a little sober about it. It's been 14 months now. And so, for example, ChatGPT looked like it could code really well, but actually there hasn't been like a panoply of new software that's been created because of ChatGPT, for example. And there's lots of other things that haven't happened yet. And it doesn't seem like we're necessarily going down that path. So there's some sobriety there that I think needs to start setting in. And then, okay, but let's just assume ChatGPT, or LLMs, or something else, or some combination of LLMs with something else, or just assume there's some advance that makes computers super intelligent, or at least as intelligent as people. Does that mean they're going to sort of exterminate people? I think it's up to the designers to some degree. I mean, there's no reason why intelligence has to be malevolent. I mean, I think the reason why, dumb animals are malevolent too, right? So in the animal kingdom, right, there are plenty of animals will eat each other and are quite savage. And so humans, I don't think we're any more, you would know better than I would, but I'm pretty sure we're actually not the most violent animals in the animal kingdom. It's just that we have more technology to sort of industrialize our violence and do it on a larger scale. So basically, that's the thing. I think, we also know plenty of people who are not that intelligent, but are malevolent. But we also know plenty of people who are very intelligent and quite kind and sweet. So I just think this association with intelligence, the reason we have intelligent beings on Earth that are basically bad people right now is a result of natural selection, the competitive environment in which they evolved, not a result of anything intrinsic to intelligence. So I think I think to me, the real danger about AI isn't that it's going to spontaneously decide to exterminate humans. I think it's someone will invent it first, invent AGI or human level AI first, and use that as a tool to sort of achieve domination in sort of a malevolent way. So you can think of it as the bomb, right? It's just, that's a good analogy. I think like, what would the world be like if the Soviets or the Nazis invented the bomb first? I think it would be radically different. In fact, I think it's an underappreciated sort of element of American history is that basically that hard to think of another empire in history that would have invented something as dominant as a nuclear bomb and not immediately have taken over the entire world. So basically, who got the bomb first really mattered a lot for the unfolding of human history, and I think that's the thing to worry about in AI. And you're not going to be able to stop. You might be able to stop American companies from building AI or American researchers, but you're not going to be able to do, stop Chinese companies or other countries and all over the world. Assuming ISIS had good AI researchers, there's no way you're going to stop them from developing, a good.
All right, yeah,
a good AI. And so basically, that's my take on it. I'm not too. There is something to worry about, but the thing to worry about is who invents AGI first, not that AGI itself is gonna cause a problem.
Yeah, I knew this. I knew this was your opinion. So we've been talking, like me and you have been talking about artificial intelligence, on the general level. We've been talking about it for a while since I've met you, but since you said 14 months, since ChatGPT came out, GPT 3.5/4, whatever, wherever we are. LLMs, have shown us these amazing powers of verbosity and all this stuff. Over the last 14 months, have you updated your projection? Because, when we initially talked for the first couple of months, you were pretty energized. Some of these arguments you had, already, told me. And there were people that were saying, humanity has 12 months.
Right.
We're 2 months past 12 now.
That's right. Yeah. You probably remember I was more skeptical about all those claims even back then. To be honest, I was impressed by how good it was. Like I wouldn't have predicted. So I'm not going to say it wasn't advanced. I don't want to sound like I'm I'm putting a wet blanket on LLMs or ChatGPT. It was an amazing thing. I mean, we're using it in our company, and it's amazing. And it's incredibly useful and super important. But you can be super important without actually ending humanity. And so, yeah, have my views changed? I'll be honest. I mean, even though at the time I was one of those people who didn't think in 12 months we were going to out of business, I still am a little bit surprised at how slow things have advanced since then. And I think, I don't know what to make of that. So I think there's something inherent to like industrializing, corporatizing something where, all these great startups and invent something really innovative and then they never do again. They just spent all their time optimizing, growing with their original product. Right. And so is that happening in ChatGPT, or is there something inherent to the actual technology that it's actually already plateaued?
So one thing that I'll say, and you said your company, we're gonna get to that, listeners, but you said, like, in terms of you're talking about like what you anticipated. There are people that are saying LLMs are running into limits. Another thing that I have to say is I have read people who said computer scientists who studied who work with LLMs, who said, well, like a year ago, I just didn't think it was possible that ChatGPT could do that GPT could do what it's doing. These are the people who actually know the theory the best.
Mm-hmm.
And the fact that they made an incorrect prediction means that we just don't know what's really going on some deep level. So for example, with Newtonian mechanics, just to make it clear what I'm getting at for people, look, we understand if acceleration is not constant in a vacuum, what the hell is going on, right? Like Newtonian mechanics, like we know the model, we know that acceleration, whatever is constant, all of these things, like these are some parameters that are fixed. We have a good handle on it. With some evolutionary stuff, I can like talk to you and be like, okay, what's going on here? Like we have certain predictabilities and regularities, but my inference from the fact that experts, quote unquote, in the field did not anticipate what happened means that we don't really know deeply what's going on, which means it's going to be incredibly hard for us to predict whether it's going to increase linearly, exponentially, plateau, whatever.
It's true. It's a good point. And so I think we should also apply that to so your point is on sort of the pessimistic experts. We should also apply that to the optimistic experts, and definitely to the optimistic neophytes. And so yeah, you're right. At some level, we have to have some humility. We don't know what's going on. I mean, to me, a couple things make me think there will be a plateau. One is that things have come along every 5 or 10 years in AI that really have surprised a lot of people, including the experts, and caused a lot of optimism and then plateaued. So there's 5 or 10 plateaus like that in the history of AI. We've talked about a few of them. So just from that sort of meta-historical point of view, there's some sort of reason to make that inference. The other is, things I said about the slowness of the progress since then. And I think if you I'm one of those people who are, if you'd asked me 3 years ago, 2 years ago, whether it would be this good as it is today, I would have been skeptical. So what was I wrong about there? I think there's a couple of things. I think a lot of what's going on that makes it look impressive, basically, is that it's regurgitating other people's thoughts. So there is a sense in which most of the useful thoughts and ideas and concepts and expositions you'd want to have been already sort of document on the internet somewhere. And so it's really good at just assembling those things, and it's doing a better job than I thought it could. But I can still give it some extremely rudimentary reasoning or planning problems, and it's horrible at them. So anyway, I think that, your point is well taken. We all need to have some humility. And I think, if the only answer really is, if you really are worried about the future, then you want to be the one who's building it. Yeah.
I'm smirking a little bit because I'm just like thinking, I use ChatGPT probably 2 out of 3 days. A lot of times for like basic stuff. Basically, I think the primary thing that ChatGPT has done is I use it like it's a supplement to search, probably a complement, probably equal now. And also, there are certain things like, give me a CSV table. I mean, something that I can do or something that I can code with like some SQL queries or whatever, SQL, Python, whatever. But now I'm just be like, just do it, like assemble it, Okay. But sometimes ChatGPT just bullshits me about something I know. And I'm like, what the fuck? Like, what the fuck? Like, come on, man.
You can get that from your friends.
Yeah, I'm like, you do not know what the fuck you are talking about, and you are trying to bullshit me right now. Are you serious? I mean, again, like this is like the humanization aspect, where it's like I literally will blurt out, like, what the fuck? Like, are you trying to say here? And it'll go off.
I mean, one way to think about that is, what it's trying to do is impress you with how smart it is, and if it can do it by actually solving your problems precisely, or by actually someone else has solved your problem and it's just regurgitating that solution, it'll do that. But the minute you put it in a situation where it has to actually innovate a little bit, then it's going to start sort of, confabulating and making stuff up. Yeah.
All right. So, your company, we've been talking about AI, the pros, the cons, like the history of it, your history with it, your pessimism, your optimism. You're obviously delusional because you're a startup founder.
Right.
We can say I like, a couple of years ago, I don't remember. It was a couple of years ago. I feel like we've known each other longer, but since the pandemic, I feel like a lot has happened. I met you at a party, I think, I don't know. It might've been 2021.
Yeah.
Yeah. Actually, no, I met you at dinner, 2021, right. September. Yes. Okay. And then I kind of forgot about you. And then I met you at a party, but anyway, keeping it real. Because you were at the other end of the table. Remember that?
I do remember that. And I'm surprised you remember the actual date. It means you wrote it down in your journal, or you wrote it down in your diary.
No, I remember. But in any case, the diary is my brain. But so you were saying basically you're just like, don't do a startup unless you really want to do it. It's kind of insane. And you have a startup. So you're insane. We've established that. But your startup is artificial intelligence, which like that's better than all the non-artificial intelligence ones when it comes to funding and traction and visibility. Just going back and like going more into like business mode. My startup also has AI in it. And we actually had that before. But anyway, I think I'm not going to talk about like AI and biology and health, but I think we talked about Eliza, the therapist. I'm just going to say really quickly, there is already a lot of evidence that AI is going to transform simple diagnostics. Okay. I just know this because I've seen it happen. Seen it happen before my own very eyes. Basically general practitioners, nurse practitioners, they need to step up their game in terms of the value that they add and figure out what they can do, because a lot of the basic stuff is going to be taken over by AI. Like you are going to have, you're going to query an AI when you're sick for a lot of the basic things, Yeah.
I mean, you could predict 80% of your interaction with your GP by looking at WebMD. Right.
Yeah.
Like if you go there with yeah.
But I think the issue with people, and like 20 years ago when WebMD first came out, people were like, "Oh, people aren't going to go to the doctor." The reality is though, people want that human experience, and frankly, the LLM, the spit back, GPT spitting back out at you verbosity is actually what people want.
Yep. No, absolutely. And I mean, again, hugely, I can imagine it transforming a lot of things, and that would be one of them. Absolutely.
But you're doing something different, and I know a little bit about it. But like, just like tell the audience, like, what's the thesis of your company? Where you at? Where do you want to go? What are your ambitions? I mean, that's a lot there, but just start with the thesis. Give the, I'm not saying elevator pitch because like we're not talking to VCs here, but you know what I'm saying, so people just can understand where you're coming from, what Dry is.
Yeah, absolutely. I mean, we're interested in human progress and accelerating it, and if you look at. And if you look at basically in our thesis there is that, the entire world runs on software right now. I mean, you've heard the expression software is eating the world. This conversation is totally mediated by software. Any podcast where people are complaining about technology is actually using technology to complain about technology. And, you want to go from A to B. If you want to drive your car, that requires software. If you want to rent a room somewhere, everything, entire society, from science to business, to intellectual life, to your family, et cetera, it depends at some level on software. And so the problem is that software is an input to the entire economy. The need for it is growing exponentially because the economy is growing exponentially. But the supply of programmers is not growing exponentially. And in fact, software is getting more and more expensive to produce. And so I claim that there's a huge amount of progress that's not happening because we don't have the software to create it. We don't have because software is so expensive to produce. So one analogy is with energy prices. So, the price of gas, for example, let's say it's $3 a gallon. If the price of gas went to $30,000 a gallon, the economy would collapse, right? If the price of gas and all other, electricity and everything else, if it all went up 10,000 times, if the price of energy went up 10,000 fold, the entire economy would collapse because the entire economy runs on some form of energy. Anything with automation, anything with electricity, that's energy. And when you make that 1,000 times or 10,000 times more expensive, then basically it's either too expensive to do. People aren't going to invest in new technologies and new companies because basically they don't have the actual resources to pay for the energy. They're not going to be profitable companies because their input, which is energy, is so high. And so try to imagine a world again where we have 1,000 times, 10,000 times higher prices in energy, and think of all the progress that's collapsing. I'm claiming that change in levels of progress is what would happen if we made software 1,000 times, 10,000 times cheaper to produce. Basically, we have $30,000 a gallon software. We don't know all the software all the progress we're missing out on because we've never seen $3 a gallon software. And so what our company's trying to do is make software several orders of magnitude cheaper to produce. And so other people are trying to do that. There's a lot of hype that sort of LLMs are going to be able to do that. Not so far, not so, it hasn't happened. Lots of ways of approaching this. But we have a platform that helps people build today certain classes of software 1,000 times faster. Literally, as this is released or soon afterwards, we'll have launched something at dry.ai, dry.ai. And that's our goal basically, is to let people build again software they need much faster. And it's not just a matter of human progress; it's a matter of dysfunction in society. That basically a lot of everything people complain about social networks, they complain about search engines and so forth. It's really hard to build your own, because it takes thousands of programmers to do it. If you could actually just build your own software, your social networking, your searching would be much better. Your work would be much more efficient, more pleasant. You wouldn't have to grapple with sort of a Frankenstein of other software packages to get the simplest thing done. And that's in a nutshell what we're working on. And so some early applications of that would be things like we've done for you, basically. So, you're using us for, we created a Razib GPT, where we take your writing.
I'll put a link to that.
Yeah. We took your writing and we created a ChatGPT out of it. Just for you. You could go there and say something like, did the Basques have Indo-European genes? And it'll give you a very thoughtful answer using, your voice, and using just the data in your writing. Another thing we've done, I don't know how much you want to talk about this, but basically we created an RSVP app for you, some dinners you host sometimes, that has certain characteristics that are just, you can put your dietary preferences in. It's anonymous, this or that.
No feta.
Exactly. Another thing we experimented with was creating sort of a Yelp just for people who like authentic restaurants, which a lot of your sort of readers do because they're just into sort of understanding these other cultures and food from them. And so these are all things basically you can do. Everything I just mentioned, you could do it in an hour or a day on Dry. And that's in a nutshell what we're working on.
I mean, what you're alluding to here is just like there are things. So, for example, to get a computer that you could use, you had to be a hobbyist that would assemble it together and order the parts. And, eventually there were kits that people made. The kits simplified it. And then So the kits would be like kind of more like, the IKEAization of home computers. And then finally, people got this idea of just like having a pre-assembled computer that you just get, and compute, but I mean, they're pre-assembled, but they're not all the same. It's, there was this idea that everyone would have the exact same computer actually when we were young. But that's not true at all. People like different colors, but yeah, but they actually like different preferences, different parameterizations, basically, of the computer, which is the abstract class. So when it comes to software, a lot of times, people, they have like some tweaks that they want to make, but it's the same thing. The problem right now is with software, you have to build. I mean, yes, like there are pre-built modules, but even then, that requires some technical skill to get the modules to work together. The debugging is a huge issue, et cetera, et cetera. So any customization is total pain in the butt. Using just the exact same software package is easy. So you go from like using the exact same software package, okay, that's totally user friendly, to okay, you need to rewrite the code. Totally
That's
not
right.
user friendly. So Dry would be in that spectrum, obviously, I think towards the user friendly end, but it allows the individual to make some changes without having to go into the code.
Yeah, it's a great analogy. I mean, right now, basically, the analogy of building a house, that if you want to build a house from scratch, you need to get nails and wood and steel and et cetera, and drywall, and assemble everything piece by piece. And maybe in two ways of making that simpler. And that, again, that takes a lot of knowledge and a lot of time and a lot of expense and a lot of labor. Two ways of making that simpler are, so one is basically just buy entirely sort of prefabricated houses. Problem is you can't customize that. And the other thing might be, well, let's take like the modular approach, which is, and what I just talked about, buying your own house, that's like cloning someone else's open source package or installing a template or something like that. That's just something else someone has already built. The other thing you could do is build stuff from, with these bigger modules. So rather than using wood and nails and drywall, you like just buy a wall. And you just assemble walls and floors together. That would still take a lot of work. Like you alluded to, you still have to be quite expert and take a lot of labor and expense and so forth for that. Ideally, what you'd like to do in Dry is say something. And so what you do like to do for your house is like build me a 3-bedroom, 2-bedroom ranch in sort of like a mid-century style. And with a large, great room, open floor plan, and you just say that, and it creates the design for you.
The command prompt world.
Exactly. You'd like to be able to like specify stuff at a very coarse level like that, and have it the house automatically created for you. But then, if it's not exactly what you wanted, then you could go in and customize it the way you want. And so that's kind of the middle ground we're trying to achieve. That basically very quick creation of software customized just for your need, but also the ability to hyper customize it as much as you want.
Yeah, I mean, okay, so again, I don't want to show my company, but it's interesting that we're actually in parallel tracks here. Like you're focused on software and we're focused mostly on genomics, like other life sciences potentially. But, our dream right now, what people do to get the variation that, geneticists and stuff use in diagnostics and all these other things, they have these like labored pipelines that they're kind of like handcrafted, artisanal. And yes, they're very extensible, but people don't want to break it. All of these, there's just massive issues with the maintainability of the code and whatnot. Okay. Then there's like out of the box turnkey solutions. But the problems with those for a lot of scientists is like, okay, but then I'm like stuck with the presets. Okay. Yeah. Okay. So like, so what do we do? So, what I told recently, I was in San Francisco at the JPM healthcare conference. I was like talking to somebody about it. I was like, look, the way I'm imagining is you have a command prompt. You're like, I have a mushroom and I want it at this quality threshold. And I need at least this many markers. Assemble a workflow and run the alignment and give me that variation. And then the command prompt, will give it into our artificial intelligence and like assemble an appropriate pipeline with the essential modules and stuff like that. That's all people want. They want some customizability, I mean, it's basically like they want some freedom, right? And that will make, and like my argument is like, okay, that will result in more science, more productivity, blah, blah, blah. Exact same thing. Like basically, and we have this in the notes here, industrial revolution, unlocked all this energy, The agricultural revolution unlocked all this energy. Time is energy. Time is money. This will unlock, our lives in a lot of ways. Imagine not having to go to checkups. Imagine, basically human doctors would be extremely value add professionals. Now that means that there's a lot of doctors who are sitting on their butts collecting rents who are going to be scared. But, if you got skills, that's going to be clearly obvious. Similarly with software, obviously some people are like, oh, well, now my job, like refactoring this or that is gone, But the reality is the software is a thing that we use, a tool that we use. And, you don't have to be a specialist in the tool. I mean, I have a friend who learns a new programming language every 3 or 4 months. He's just weird, okay? Like, I mean, that's just like weird, and like it has like no practical benefit,
Right.
So.
Well, I mean, you're making a good point that, historically, first of all, I mean, there's a lot of historical ignorance in these conversations where people talk about as if automation is this new thing that's happening that's going to change the world. When, automation has been happening for 250 years at least through the the Industrial Revolution. And what you learn there is that, the unemployment rate hasn't gone up a lot. It's probably gone down since, 1870, 1880, whenever you want to say the Industrial Revolution, 1770, 1780, whenever you want to say the Industrial Revolution started. So, and the other thing is, in some sense, automation makes workers more productive and makes them more valuable. And so, a contractor with an electric drill, as opposed to sort of can just do a lot more than a contractor with a manual drill. So therefore they can generate a lot more value. It makes their labor more valuable. So it's not something, I mean, obviously there's always in the near term, some people are negatively affected, but overall, it's a great thing. It's been happening for a long time. I don't worry about it. I mean, there might be problems to deal with, but I'm just saying that, let's deal with them and not sort of kill the future, basically.
I mean, the reality is it's already happened in software multiple times. It used to be, like we write code in high-level languages.
Yeah, you're right. People actually, when programming languages were first invented, people thought they were going to put programmers out of business. Because before that, programming was either punching up little bits on punch cards or adding assembler code or machine code. And they thought literally programming language was going to put programmers out of business. But it was the opposite, of course.
Well, I mean, the listener, I mean, a lot of listeners who are Gen X might know this if you're a nerd, but, Microsoft Word, which is, for a while it was, before Google Docs and other things, but, there was a period when it was Word everywhere. Well, Word was basically a clone of something called WordPerfect. Now, WordPerfect, was actually arguably the better product. And one of the reasons it was the better product is because it was written in assembly. But so basically it was closer to the machine code. It was closer to the source. And so it was optimized and perfected, and, it wasn't going to like be buggy and crash on you and stuff like that. The problem with WordPerfect is it was released at a much slower cycle than Microsoft Word. Because Microsoft Word, I think it was put together. It was like, is it Visual Basic, or like it was one of the Microsoft, for software people out there, they have these like, integrated development environments, as where they like put together the modules and stuff. Yeah, so it's put together. Yeah, Studio. Yeah. So they Visual Studio. They put together very quickly. And so they kept releasing it really fast. And, eventually WordPerfect kind of went out of business. I think it was acquired. I don't know if the brand is still around, but my point here is, yes, WordPerfect was great, but it was released so slowly that it ended up being lapped by Microsoft Word because they kept releasing and iterating and improving. Imagine a world like that for like all types of software, where you don't have to, learn how to write Python or C or whatever to release some great idea. And, in terms of productization, like a lot of times it's just a user experience, which is not like a code thing. It's an idea.
No, you're absolutely right. That basically the complexity of software makes it really slow to actually iterate on it. And you get less innovation that way. I mean, even a simple thing like for Facebook to go from liking posts to reacting to them with multiple sort of possible ways of reacting to them, that took months and tons of programmers to achieve for one simple little feature. And so, and going back to the assembler thing, I think that's in your command line way of talking about stuff. Today, if you think of what a programming language is, or what the way people have to actually program today, is they're translating the design in their head of what they want to build into something a computer can understand. And in some sense, what you were talking about for Generate, basically as a command line is a way of basically describing what people want to do in human terms and letting sort of your software translate that into the actual analysis the statistical package can do. So that's something we're aiming for as well in our company as well. I think that's one advance that's going to make programming easier to building software easier, is to, rather than force people to translate stuff into computer terms, to be able to just state stuff in their own terms.
Well, May, I guess as we're closing out, we're talking about a great conversation. You're a trained computer scientist, cognitive scientist, artificial intelligence researcher. Now that you're an entrepreneur and you're in the startup space, you're trying to make things simple, productize some of your insights. Do you use your background as an artificial intelligence researcher every day? I'm just curious. Do you think about that?
Oh yeah, absolutely. I mean, basically the goal of my research was to understand, what is the difference between humans and computers, where humans can still learn stuff much more quickly than computers can, right? So I wanted to be able to have something to learn. My master's degree is actually in child psychology, because I wanted to.
What?
Yes.
Well, you just blew my mind, bro. Yeah, I'm just freaking out right now. People can't see my face.
I was extremely earnest and serious, and I said, "Look, I want to make computers able to learn. I should understand how humans learn." And children are the best learners. And also, in addition, in the history of science, it's always best to start with this. It's often been best to start with a simple system. Sort of in physics, that was the inclined plane or planetary motion. Drosophila in biology has been a good model for things, for a lot of things at least. And so I figured, well, human cognition, child cognition is simpler than adult cognition, so a nice microcosm for studying cognition in general. And so what I did as part of that was develop sort of a framework of reasoning and learning and intelligence and planning that tried to understand what are the core building blocks of all of human cognition, right? Because human cognition, let's say, reached this peak in evolution 50,000, 100,000, whenever it was, right? It was relatively recent in time. And so maybe there's been some evolution since then, but it can't have been a lot. So basically, what you and I are using right now to have this conversation, or what people, when they're doing stock trading, or when they're talking about politics, or when they're planning sort of, organizing science, they must be using parts of their brain. They must be using brain mechanisms that evolved to do what people did 100,000 years ago, which was moving around, understanding the physical world, basic social interactions. So I developed this theory that sort of found a substrate of these core sort of primitives that could explain all of human cognition. And that's at the foundation of sort of what we're doing now in my company as well. It's like, if you have these primitives and you do a really good job of implementing them, then you can crank and build a whole panoply of things on top of that much more quickly than you can just using brute force data or brute force search or anything like that.
Well, so as you were talking, I did two things. One thing I actually did is I asked ChatGPT, Dolly, I guess, to create an image of a Neanderthal doing a mathematical proof, and it's not a very accurate. It looks more like a chimpanzee doing a mathematical proof. Anyway, that's neither here nor there. Sorry, these are the creativity that AI is unleashing.
Sure.
But the second thing is I loaded dry.ai. And it's like, build your own AI-powered everything app. Build a smart space powerful enough to be your own internet, and as simple as ChatGPT. It's easy with no coding. So, you already talked about that. There's learn more. And then it's Razib GPT is on that page. So hopefully when people are listening to this podcast, that'll be there. It's been great talking to you. I mean, I've known bits and pieces of this for a while, but you kind of put it all together. I hope the listeners enjoyed drilling down on some of the details. Hey, no one's forcing you to listen to this podcast. If you do not enjoy, figuring out a little bit what back propagation, just a little bit what back propagation is, maybe you should train yourself to listen to another podcast. I don't know, because I don't know where you think you are. I mean, you're going to be hearing about stuff like this, right? But it was great talking to you, Nick. I will see you around town as per usual, but also see you on the internet, and really wish you the best on everything. Obviously, we're kind of in parallel tracks in some ways, and so what works for you will work for me, hopefully, and vice versa. And it was great talking to you. I hope you enjoyed it too, man.
Yeah, likewise, Razib. I didn't realize the parallel. I didn't realize exactly the connection between you guys are doing in some sense like a low no code sort of genetics software platform. So that's you articulated sort of the benefits of that quite well, and it's glad we're working on that, and I enjoyed talking to you about it. Oh, go ahead.
Yeah, for sure. No. I mean, I've actually never. I mean, you use the term low or no code all the time. I've never actually used that term in relation to generate. So I'm going to use that now because I think that the issue is we don't work with devs. We work with scientists, and so somewhat different lexicon, but the same concepts. But
and there's a class of investors who will understand what you mean as soon as you say that. So might help you there.
Inshallah. All right, I'll talk to you later, man.
All right, man. Good talking to you. Take care.
Whole genome sequencing is used for adults and children every day to assess risk for thousands of diseases. Orchid, a genetics company led by scientists from Stanford, is able to do this for IVF embryos. Now, instead of waiting for a diagnosis, parents can assess if their embryos have genetic variants known to cause severe conditions before their child's even born. No other tests can detect these issues so thoroughly or so early. So check them out at orchidhealth.com.
This podcast for kids. This